Hello students, here in this video we will see the GE 8292 Engineering Mechanics Unit 4 Dynamics of Particles. In this, relations of velocity, acceleration and displacement. Relationship of velocity, acceleration and displacement. The relationship of velocity, acceleration and displacement is obtained from equation of motion in a straight line. This is the rectilinear under the rectilinear problems. Okay. Uh, Let us consider the body which is moving in the straight line. The body is moving in the straight line. It is not the curvilinear problem. This is the rectilinear problems. The part is moving in the straight line. Let's see the some notations, some variables. My small u equal to initial velocity of the body in meter per second. Okay, velocity unit is meter per second. V equal to final velocity of the body in meter per second. T equal to time in second during which the velocity change from u to v. I mean velocity changing from initial velocity to final velocity. S small s equal to distance traveled by the body with respect to time. Okay, and a equal to acceleration of the body. Okay. Uh, First, equation of final velocity. From this equation, you have to find the final velocity of the body. Okay, final velocity of the body or object, anything. Okay, change of velocity. Change of velocity equal to final velocity to minus initial velocity. Final velocity minus initial velocity, we can find the change in velocity. Velocity different, we can find the velocity different. Okay. Here the final velocity is equal to small v and initial velocity is equal to small u. Okay, minus v minus u. Okay, rate of change of velocity. Velocity changes, obviously we know rate of change of velocity is equal to acceleration. Here change of velocity divided by with respect to time. Here the change of velocity equal to v minus u. V minus u divided by time is t. Okay. But rate of change of velocity is equal to acceleration, so acceleration equal to a. Okay, now equating this equation, rate of change of velocity a equal to v minus u divided by t. Okay, next resolve this equation. At equal to v minus u. Okay, now v equal to at plus u. Next v equal to u plus at. Okay, this is the equation taken as the equation 1. This is the equation used to find the final velocity of the object or else initial velocity of the object or else find the time of the object or else find the acceleration of the object. Okay, depending on the problem, using this equation you have to find the initial velocity or final velocity or acceleration of the body and time. What's the time the object is traveling? Okay, all the things you have to find from this equation. Okay, this is the equation 1. Next, equation of the motion for distance covered. Okay, from this equation you have to find the object. Object is how much distance covered, how much distance it is traveled. The distance should be find from this equation. We know that average velocity is equal to initial velocity plus final velocity divided by 2. Okay, this is the average velocity u plus v divided by 2. Okay, distance covered equal to s equal to average velocity with respect to the time. Velocity with respect to time, average velocity into time. This is distance. Okay, u plus v divided by 2. Okay, into t. U plus v divided by 2 into t. Okay, substitute this v value from the equation 1. This value you have to substitute here. Okay, so S equal to U plus sorry, yeah, U plus 80. Yeah, okay, U plus 80 divided by 2 into T. Okay, resolve this equation. Add U plus U, 2U plus 80 divided by 2 into T. Next, take 2 as the common here. Okay, 2 to cancel. So U plus 1 by 280 into T, and next step multiply the T into inside. Okay, so UT plus 1 by 2 80 square. Okay, so S equal to UT plus 1 by 2 80 square. This is the equation 2. Okay, from this equation you have to find the S, that means distance covered by the object. Okay, with respect to distance, you have to find the initial velocity. Okay, and time and acceleration you have to find from this equation also. Okay, uh, with the data of S. Okay, and next, derivation of v squared minus u squared equal to 2as. Okay, this is the equation used to find the uh, acceleration and distance, initial velocity and final velocity. Okay, the value of t from equation 1. Okay, t from equation 1. Where is the equation 1? This is the equation 1. Here t equal to v minus u divided by a. Okay, v minus u divided by a. Okay, um, substitute this value into the equation 2. This t value substituted to here equation 2. So we can get s equal to u into v minus u divided by a into 1 by 2a into v minus u divided by a square. Okay. Uh, Now resolve these equations. Uh, okay, resolve this equation. Finally, we get the v square minus u square equal to 2as. Okay, and this is the equation used to find the motion of the object. Okay, let's see the problem. In equation 1, 2 and 3, a is the linear acceleration. Okay, linear acceleration is the positive acceleration. If instead of acceleration the retardation is given, the value of a is, this equation should be taken as the negative. Suppose the value is given in the retardation, that means in negative retardation or deceleration. In the case the a is taken as the negative sign, the retardation is the negative of the acceleration. Okay, so some of the important equation you have to note it down. Okay, first is v equal to velocity equal to change in distance with respect to the time. Okay, ds divided by dt, and acceleration, change in velocity with respect to time, dv divided by t dt, or else double integration of the sorry double differentiation of the uh, distance, d squared s divided by dt squared. Okay, and then equation 1, v equal to, you need to find the final velocity, v equal to u plus at. Okay, and then equation 2 equal is s equal to u plus t plus 1 by 2 at square, and equation 3, v squared minus u squared equal to 2as. Okay, this is the important equation, you have to note it down. Okay, next, see one simple problem. A car is moving with a velocity of 15 meter per second. The car is brought to the rest by applying the brake in 5 seconds. After the applying the brake, the car is taken time to 5 seconds to rest, take the rest or stop. Okay. Determine the retardation. Retardation means once applying the brake, the acceleration will be reduced. Okay. The car is going on some velocity. Suddenly we applying the brake, the car acceleration will be reduced. So it is called the retardation. So next, distance traveled by the car after applying the brake. Okay, after applying here after applying the brake, the car will be take the 5 seconds to stop the uh, rest the car. Okay, so that 5 second car, how much distance it will be covered, how much is distance will be traveled. Okay, these two things we have to find here. Okay, first given what are the data given in this problem. First, initial velocity. Okay, the car is moving in the velocity. This is the taken as the initial velocity is equal to 15 meter per second. The final velocity is equal to v, because after applying the brake, car will be taken to the rest. So there is no velocity. While car is in the rest, there is no velocity. Car has been brought to the rest. In rest position, car has not any velocity. So final velocity equal to 0. And time. What is the time taken to stop the car? Okay, t equal to 5 seconds. Okay, first we have to find the retardation. Okay, let's see the a equal to acceleration of the car using the equation 1. Okay, from this equation we have to find the acceleration. Okay, here the final velocity and initial velocity and time, and from this equation we have to find the acceleration. Okay, already I told. Let's see. Okay, v equal to u plus a t. Okay, here the final velocity is equal to 0 and initial velocity equal to 15, plus acceleration we have to find into time. What is the time taken to stop the car is 5 seconds. So applying this all values here and resolve this equation, I have to find the acceleration. Here the acceleration is equal to minus 3 meter per second square. Okay, acceleration unit is meter per second square and the velocity unit is meter per second. Okay, here the retardation is equal to minus sign. Okay, minus a. Okay, already I told here retardation is the negative of the acceleration. Instead of acceleration is retardation is given, and the value of a is this equation should be taken as the negative. So here minus a equal to minus into minus 3. Okay, so 3 meter per second square. Okay, retardation equal to 3 meter per second square. Okay, um, and second question, distance traveled by the car after applying the brake. Okay, using this equation 2, this is equation you have to find the distance. Okay, so from this equation you have to find the distance. We know the initial velocity and the time and the acceleration and also the time. Okay, we will apply the all values and we'll find the final result. Okay, here the initial velocity is 15 and time is 5 second, plus 1 by 2 into acceleration is equal to minus 3. Okay, my acceleration, you don't apply the retardation value, acceleration value. Okay, acceleration value is minus 3 meter per second square. Okay, so minus 3 into 5 square. Okay, resolve this equation. 15 into 5 equal to 75, and 3 into, solve this equation, 3 into 1 by 2, 3 by 2 into 5 squares are 25. Okay, solve this equation and find the value is 37.5 meter. After applying the brake, the car will be moved the distance of 37.5 meter. In that 5 second, the car is moved in 37.5 meters. Okay, thank you, student. I hope you understand the relationships of velocity, acceleration, and displacement. Okay, uh, thank you so much.